So we're going to talk about patterns and anti-patterns for continuous software updates. When you see the word anti-patterns in the title of the talk, expect a lot of failure stories, which is obviously always fun and horrifying. Today won't be any different. So first of all, I want to start with asking the questions, why at all do we even update the software? It's something that Adam mentioned and asked, what do we think? Do like people update their devices or what's not? But and that made us thinking. But the bigger question, even our desktop software or server software, why do we even update? And I would claim that there are two main reasons. The first are users. What do users want? They want features. When do they want them? They want them now. Yesterday is also a good one, right? So we have a constant pressure of more and more features, more and more cool stuff, and if our competitors updating their software faster, we obviously lose market because we didn't update ours. That's kind of, I hope it makes sense, I hope it's common sense, and when we think about it, we all realize it. So obviously that's one reason. The other reason is, right, as an example, I don't know if you remember, in the 90s, you wanted to update your device, no one updated their device, you just bought a new phone, right? There was no competition of features. And if you had a phone that had a snake in it, here you go, this is your competitive edge. You can sell more devices with the snake than your competitor without the snake. I will claim that this is why Nokia won, because they had snake and Motorola and everybody else didn't have snake, right? And then, oh, this one is cool. You remember that? This is where you had a data cable. Who remembers data cable? Data cable was different than your charging cable, and you should have bought it separately because it didn't come with the phone, and then you could update your software, but it wasn't meaningful update. You updated to get what? You couldn't get a snake if the phone didn't support snake, right? If you wanted snake, you had to buy a new phone anyway, so it was kind of pointless. We're geeks, so, oh, there is a cable that I can connect my phone with my computer, let's do it. But it was pretty pointless back then. But then, everything changed. Everything changed, obviously, with the iPhone, and boom, updates arrived to our smartphones, and the war for features began. Right? And then you still update it, and you push the button to get an update, and all the apps and everything. And today, obviously, you get all new features without the update. You go asleep, hopefully in a couple of hours after I finish here, and then you wake up tomorrow, and you fire up Twitter to share how amazing this talk was, and you find a new feature there, right, that you can edit tweet. Not gonna happen, imaginary, but one can hope, right? And then it can happen overnight without even your intervention. So that's obviously one feature, one reason of why would you want software update. The other one is security. And here we are looping back to Ada's talk. As every company becomes a software company, security vulnerabilities are the new oil spills. Kit, that didn't survive, would enjoy this quote because this is his quote. But it's actually, there is something into it, right? Today, the biggest catastrophes that we experience, most of them are based on security vulnerabilities. Think about Equifax, think about ransomware in national health system. There are huge stories about huge problems that come out of software vulnerabilities. So let's talk about software vulnerabilities, and let's talk about your driving lessons when you got your driving license. Remember that? That's the time to stop. Time to stop built from two different parts. There is the thinking distance and the braking distance, remember? And they have completely different dynamics. This is neurons firing in your brain. This is electricity gets from your eye to your brain. You realize that you need to start stopping. And those are completely different mechanics. This is like pure, you apply the brakes, you have your car moving forward, so you have the energy that keeps moving forward even after you apply the brake, all this stuff. Two completely different stories come together to actually affect how the car stops. It's exactly the same with patching security vulnerabilities. When you patch security vulnerability, you have three different, completely different actions that you need to take. All of them is comprised of the time that you react to a vulnerability. So you need to find the vulnerability or the exploit or the fact that you were attacked. That's one process. The second process is you need to fix it, either by writing code or by updating a dependency. And that's a completely different process of that. And then, after you found that you need to patch something, and you patched it, you need to make sure that it goes to production. And obviously, the first, and I'll give you a couple of examples. So first is what it was 2 years ago, National Health Service in the UK was attacked with PETA, non-PETA, whatever ransomware. That was a ransomware attack, their computers and medical equipment, including X-ray and dialysis machines and what's not, was actually all completely shut down because of this ransomware attack. And here is their path to their path to mitigate. So identify, obviously, identify the problem immediately because they all were shut down. And then they fix it. In their example, they run on Windows XP. So they should have updated it to whatever Windows 10 or whatever. And then deployment. And deployment of the fix. Deployment of the fix is updating to new Windows. Since new version of Windows were out after Windows XP, it's been years, right? They didn't update. So actually this part took them years, and this is why obviously they had this problem in 2017, vulnerable Windows XP machines. Another example is Equifax. So I live in California, and Steve here from California as well. So we feel the pain. You can just laugh on us, but again, 2 years ago, 17, yeah. How many? 185 million of records were stolen from one of the credit agencies in the US. And this is a big deal. It's actually much worse than the credit card leak because having your credit file, an attacker can open any number of accounts and get credit cards and actually pretend to be you and ruin your life. And Adam mentioned how much the social security number costs? $10, right? And that's because they have plenty of supply. 185 million of those to sell. So they go pretty cheap. And what happened there is threats vulnerability, and this is amazing because it took them 2 months to identify that they have a leak. During those 2 months, the exploit was active, and during those 2 months, 185 million records were stolen, and then it took them. Well, the upgrade is there. There is a new version of Struts that's been there for a while. So their fix is 0. They don't need to invest any time in fixing. But deploy took additional 2 months. So they discovered there is an exploit. In June, they realized that the exploit, sorry, in July, they realized the exploit has been there since May. And they actually patched it and announced the vulnerability in September, right? And obviously Ada is much more qualified than me to talk about those two parts of how do we find that we have been breached and what we need to do in order to fix, and that's what talk her about. And I'm going to talk with you about shortening this period of time. And this is completely different mechanics, as I said, and I don't understand anything in DevSecOps, but I still can speak with you about that because this has nothing to do with DevSecOps. Another example of, so you can tell me, okay, right, those are big stories, two years ago, those are old news, and Word learned by now and move forward. This is not going to happen again. So I have bad news for you. You remember Meltdown and Spectre, January last year, 2018? Spectre did, Meltdown did very, very big waves because there was like 5 lines of JavaScript code that stole password from another application memory. But actually, Spectre, and that's another vulnerability, is a much scarier one. The Spectre vulnerability is a vulnerability on a chip, and the problem with Spectre is that it is impossible to defeat. It is impossible to defeat because the way modern chips optimize performance is by making assumptions about our code. And if an attacker can guess which assumptions the chip is going to make about our code, they can use this knowledge to predict what memory application will use and then fish for this memory and check what's in it. And the problem is that those predictions that the chips make, they make based on best practices of software development, right? And that basically means that the better code we write, the more it's vulnerable for Spectre type of attacks. And the answer is yes, that's exactly what it means. And that means that we cannot prevent Spectre type of attacks from happening. We can try to identify them, we can try to fix them, and then we need to deploy the patch. And that means that all those 3 steps are critical for our security. As I mentioned, I'm going to talk about the 3rd one. Here is what we want to have. We want to identify as fast as possible, fix as fast as possible, and deploy as fast as possible. So we're going to talk about the deployment as fast as possible. The good news are that there are companies that do this deploy as fast as possible already today. This is one of the most important documents in the DevOps industry, and it's called the State of DevOps Report 2019. It's out a couple of months now, and it's created by the organization DevOps Research and Assessment Institute that is now part of Google Cloud, and they do this report for 5 years now, every year, telling us what is the state of DevOps as an industry. And this is a very, very serious report run by scientists, Dr. Nicole Forsgren. She leads the DORA group inside Google Cloud. They actually collect a very significant number of responses in order to come up with very reliable data. And they organize the answers by cohorts, and there are different types of their low performance, medium performance, high performance, and the elite. And the elite is obviously your Netflixes, Googles, Facebooks, LinkedIn's of this world that actually do DevOps today, as we all would like to do DevOps one day. And those elite performers actually already know how to deploy almost immediately, right? So deploy frequently, on demand, whenever needed, multiple deploys a day. So if those companies are hit by some vulnerability and they manage to fix it, to identify it fast and fix it fast, deployment is not an issue for them, but obviously we wish that all of us were those Netflixes and Googles and Facebooks, and we are not. So I will give you some tips about how to become one of those, and we're going to talk about that. So obviously this is not a new idea, and the funny thing that all the agile methodologies going back to 1998, XP is that old, actually preach doing continuous updates. So extreme programming speaks about short feedback. Scrum, reducing cycle size to absolute minimum. Toyota production system, decide as late as possible and deliver as fast as possible. And then Kanban, incremental change. Those are all about releasing often and releasing fast. So those ideas are not new. Continuous update been preached to us for many years, and that's about time to get serious about it. So my name is Baruch. I'm a Chief Sticker Officer at JFrog. If you got some stickers from our booth upstairs, that's thanks to me. There are stickers there as well. Also head of developer advocacy, basically doing that, including helping organizing the conference and speaking at this meetup today. As you already noticed by now, I'm extremely entertaining guy, so that will be a very good time to follow me on Twitter on jbaruch, if you still did not. And if you are still not convinced, no worries. My Twitter handle is conveniently on each and every slide. So when you decide to follow me, you still have an option. This is the most important slide of tonight's presentation. I prepared a nice page for you under jfrog.com/show notes. You go there, you will see Yalla DevOps. You get into this page, which already have the slides. We'll have the video hopefully as soon as possible. All the links are already there. Everything that I'm talking about, including the incidents that I already mentioned, and a lot of incidents that I will mention throughout the talk. A place to comment, ratings, and a small raffle. Thanking you for being here, as if you didn't have enough raffles in the conference. That will be an Amazon Echo Dot. You have not bad chance of winning, comparing the number of people here, so go ahead and use that. So I guess I convinced you that you want to update faster. And now let's see how it works. And the example that I love to give, and just because I kind of feel at home bashing Java, that's my developer background many years ago, this is an example of Java. So Mike Reynolds, and he is like the captain of a Java ship, decided a couple of years ago by now to move Java faster. And move Java faster means going from a release cycle of 1.5 years, which most of the time was more like 2.5 years, but who counts, to a very, very fast cycle of every 6 months. So 2017, Mark announces we are going to release every 6 months. This was the time of Java 8, Java version 8. Since then, it was Java 9, Java 11, Java 10, Java 11, and Java 12. And 13 just came out last week, right? So that's like a lot of versions of Java that we all should have been updating to, because updating faster is good. And then we look at the report. This is a report from JetBrains. Again, 7,000 developers, so pretty credible. And we ask, okay, how is your Java updates are doing? Boom, 83% on Java 8. That's the same Java that we've been updating faster from it. No one moved. Well, some people moved.
It's a bit worse than on a Joker last year. Last year on a Joker, when Damir asked this, I think it was 50% with Java 9.
Yeah, no, people who go to conference are kind of advanced people and everything. This is like everybody. And this is, I mean, and then you go like, what? Didn't I just convince you and everybody know that we should update and move faster and what's not? Yeah, because people use multiple versions of Java. That's fine. And then like, what? What's going on? Why people are not updating? To understand why people are not updating, we need to understand how do we update. I don't know why this slide goes from right to left. I think that's my like Hebrew roots are coming out. But yeah, so update is available. There is a new version of something. What do we do next? Next, we decide, do we want it? Doesn't have enough features for us to want an update. If we don't want it, there are no interesting features, then, well, we won't update. If there are interesting features, we ask, are there any high risks? If there are no high risks, and fine, let's update, let's get new features, it's basically free. If there are high risks, we need to ask, do we trust this update? And again, if we trust the update, it comes from trustworthy source, then we're going to update what we're going to update. And as an example of trustworthy source for update, I would call Apple from 5 years ago, 6 years ago. As you remember, you can trust your Macs to be updated almost blindly because it always worked. This is kind of trust that we are talking about. Now, if we do not trust, the question is why? Why we don't trust a vendor without software? And most of the time, the question will be, we don't trust their processes because their processes are like that. This is the quality assurance. I can assure you there is nothing to be worried about quality. Right? And then this is where the problem lies. And I just saw a tweet from Ant Weiss, who have a very good chance of being the best speaker of Yalla DevOps. He asked a rhetorical question: is complexity the new hottest buzzword in DevOps? So I could not have a slide about complexity. The problem with quality is not because the people are lazy. They might be lazy in Dilbert tunes, but the problem is complexity. And we in JFrog, we deal with binaries, with packages, with artifacts, and we see this complexity through the number of artifacts that go through the repositories and through people's hands. So back in 2000, Agile came out, XP98, Agile 2000. Let's release faster. Release faster means let's produce more artifacts. Continuous integration. Let's build not once a month, but every time we commit something, that generates more artifacts. Continuous delivery. Now those artifacts actually make sense to keep around because they might run in our production, so we need to keep everything. And then infrastructure as code. Let's describe our servers as artifacts of software now. And microservices, well, the more artifacts we have as services, the better. And then comes Docker. Every line that we change in a Docker file produces a bunch of new artifacts that we need to take care of. And then serverless, every 3 lines of function now will be an artifact. And then IoT, boom, and here we have the huge explosion. Right? And that's like endless. And all this is complexity. And Shlomi stole next slide for me for today's keynote. This is the 175 zettabytes that we are going to have of data by 2025. And Shlomi said he doesn't know what zettabyte is. I have here. So we have petabytes, and then we have exabytes, and then we have zettabytes. It's like fucking a lot of data. And why data adds complexity? Because data makes it impossible to test anything in production scale. Because I cannot do a staging environment with zettabytes of files. Even with petabytes, I can't, right? And then people do like crazy shit. And here we start with personal stories. There will be a lot. There is a hashtag going on Facebook, I think, empty envelope from China. That's a hashtag that my wife coined after she started to get empty envelopes from China. Every couple of weeks, so she had an account in Alibaba, AliExpress, whatever. She ordered some stuff from it, but even if she didn't, every couple of weeks, she would get an empty envelope from China. Sometimes it was completely empty, but sometimes she got a white sock. One new white sock. Sometimes a piece of red tape. Another type, black cloth. Just a tiny piece of black cloth. Hairband. A ring, like a cheap plastic ring. Like completely random shit that didn't make any sense in those envelopes from AliExpress, arriving to our home address once in a while. And we're like, what is it? Is it a CIA plot? Do they check our loyalty to the United States? What's going on here? And then I have a very good friend. He's a genius, and he's just a VP of engineering with EVP of engineering with Signal Effects. Very smart guy, and he's like, I know exactly what they are doing. They are testing on production. They have some script that randomly picks entries from the production database and then test their logistics capabilities on this data, right? So they check if they can ship the right thing to the right address and what's not. They check Facebook. There is a hashtag for that. So yeah, I mean, it's extremely hard to assure quality in this complex world full of huge data. This is one of the reasons why we don't trust. So get back on how do we update. Now we know why we don't trust. And the next question is, can we verify the update on our side? And there will be two answers for that. First is no, we cannot verify. We cannot verify because it's too expensive for us to justify why we want it, or there is just not enough time to verify it. And this is what happens with Java updates. People say, our acceptance tests for all our production servers, this is scary shit. I need to update all my production servers. I don't know how many bugs Oracle have in my Java version. The acceptance tests take more than half a year. Why would I even bother if by the time I finish my acceptance test, there is a new version of Java? It doesn't make any sense. So this is why people don't update. And of course, if they can verify, it will be time-consuming verification anyway. And I just want to remind you, this time-consuming is the part that we want to eliminate. Right? So the only reason why would people even bother if they have enough food on the table. There are so many tasty features that they are ready to invest in the time-consuming verification in order to get those features. So we kind of have this trade-off of features that we really want and the acceptance test code that is stopping us from updating faster. And what we're going to do is find examples when the industry actually cheat on us and try to break this trade-off and find a way to make us update without this trade-off would make sense. So what happens now? Update is available. Do we want it? Yes, we want it. Are there hard risks? No one actually asked you because the auto update is on. And then we will update anyway. But this only happens for applications for which we don't have high risks. And some of the examples are your browser. Anyone knows which version of Chrome they're running? Not 50 million something. And you remember how we were like, what's going on with this version scheme? Why they suddenly start bumping up the versions every like 2 days? That was a psychology trick on all of us to stop caring about the version. When we got to like 47, we're like, this is just ridiculous. I don't care anymore. And this was a plot to cheat you into allowing that. You're like, fuck it, I don't know what version is it. And this is where the auto updates happens. Twitter in your browser, anyone knows which version of Twitter in their browser they're running? You don't even get this information if you want to. It's impossible to get it. Twitter on your smartphone. Now, theoretically, there is a version there. But again, anyone knows? Anyone knows what version scheme they're even using? Maybe it's a build, maybe it's a commit hash. Maybe it's a build number. Maybe it's something not even human readable. We have no idea. But how about your smartphone OS? Who knows which version of Android they're running? Exactly, version of iOS they're running? Kind of, but yeah, some people know. So this is where it breaks. And it breaks because updating your smartphone OS cannot be discarded as non-high risk. Because if we have our Netflix broken, because Netflix didn't want to update, fuck it, we're just going to YouTube and watch some cartoons on YouTube, right? Doesn't really matter. But if your smartphone now breaks because of the operating system update that was landed through the auto update, that's a big deal, right? So yeah, and this auto update is very, very, very scary because a lot of things obviously can go wrong. Now, some people are brave and do the auto update, and the rest of the talk will be how they do it, why it's wrong, how can we do better. So here's a great example. And this is, I have dates here, I think. I don't. Well, some time ago, I bought an amazing router from Google. It was called their own hub. Now it's called Google Wi-Fi. It's one of the best gadgets I have in my home. Now they do like all-house Wi-Fi mesh. It's really, really amazing. One of the features that I found personally appealing is it's a self-improving system. They have auto updates. They will just, my router, instead of depreciating in value, will actually increase in value because tomorrow it will have features that it doesn't have today, which is pretty cool. So I'm like, yeah, I want this thing. And then here I have a date, February 23rd, 2017. That's 2 years ago. I was somewhere abroad speaking in a conference, and my wife is calling me, and she's like, Baruch, kids are sitting in the dark. And I'm like, what happened? Do we have like a power outage? And she's like, no, the internet doesn't work. And I'm like, oh, why the kids are in dark? And she's like, they keep shouting, Alexa, turn on the lights, and nothing happens. And they didn't forget that there is like a physical switch. Long story short, okay, there is an internet outage, call Spectrum, call our Wi-Fi internet provider, and they're like, no, it's all fine. And then 10 minutes after, I get this email from Google. And they say, oops, sorry, we sent you an update, and by mistake, we reset your router to its factory settings. Now, I mean, now what? They cannot send a fix to my router because my router is now not connected to the internet. And they have to send me an email, but to get an email I need an internet? I was like out of the country, I got it on my hotel Wi-Fi or whatever, so I was able to tell my wife about it, but otherwise it's like catch-22. And this is obviously a problem, and continuous update pattern that we can learn from that is local rollback. So the problem, update went catastrophically wrong, and the over-and-update patch cannot reach the device. It cannot reach the device because the update broke the device. The only way to recover from that is having a version saved on the device prior to the feedback, and then if the problem occurred and the device managed to find it, so for example, for a router is trying to get to the internet and do health checks, then a local rollback can occur and roll it back. And this is an Internet of Things example, but I would claim that everything is Internet of Things. Your servers in your data center are things that connected to internet. Your cloud is a thing that connected to internet. So you cannot say, well, it doesn't apply for me because it's an IoT thing. Everything is an IoT thing. And let's talk about another IoT things, auto-updating cars. How awesome that would be, right? So here's one example of how awesome it would be. Well, car manufacturers start to understand the importance of software, especially in the age of electric cars, because electric cars are naturally more software savvy than mechanical cars. And here's an example of what happened June 2019. That's like a couple of months ago. This is a Jaguar I-Pace, an amazing electric car that had to do a physical recall to a service because a software problem in their brakes.
What?
Yes. Just read the headline. Read the headline. It didn't charge the battery while it's braking. But still, it's a problem in brakes caused by software, physical recall. What they didn't have is another pattern that we learn, and that the over-the-air software updates. Problem: physical recalls are costly, extremely costly. Also, you cannot force a physical recall. You can set a red envelope written with "open immediately, safety information inside," and the paper within will be red as well, and it will say "go to service immediately, you have a problem with your brakes." But if you throw this piece of leather in the garbage, your car won't be updated.
Why can't you force the physical?
I won't come to your service. What are you going to do?
Your car won't be allowed to drive anymore.
How it can be alive? It cannot be updated over there. Until I come to you, you cannot lock me out. You don't know how to do over-the-air updates.
You and the manufacturer tell the government the car is unsafe unless it has version 77.
And how do you enforce it? So the government said, no, 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 don't drive it. And they set another red envelope, now with the government stamp on it. Do a recall, I don't care. What do you do next?
In Israel, it's very easy. You can't pass the test.
The test is next year. I'm going to drive with defective brakes a year now. Right? And the only solution to that is implement over-the-air software updates. Because if they're over-the-air software updates, they're obviously, I can force updates on all the car manufacturers. Right? And you can say, well, you can go offline, you cannot connect to Wi-Fi. There is a simple GSM SIM card in your car solve this problem. Preferably continuous updates, but that's coming next. So continuous updates, what are they? They are like regular over-the-air updates, but better. Why are they better? I will give you another example. And this time it will be a car manufacturer that does everything right. They do over-the-air updates, and that will be obviously Tesla. Tesla do over-the-air updates great. Here's a story about phantom braking. Phantom braking is a very annoying bug in Tesla's autopilot when you drive in a highway and the highway is open and there is shiny, there is no shadows, the road is open, and then boom, the car slams on brakes. This is dangerous, this is super annoying, and this is just bad software behavior. It's a software bug, right? There is some pattern recognition that decided there is need to slam on brakes, and it is a real thing. Now, there is a rumor that the next version of Tesla software will fix phantom braking. And I really want it because phantom braking is dangerous for me. But they only update the car in batches, once in a while, every 2 weeks, every 3 weeks. So this release contains minor improvements and bug fixes. Those bug fixes fix the phantom braking. But I won't get it until they finish developing chess so I could play in the car while supercharging. The problem with bulky updates is that non-important features make me wait for the update for the important features, right? So, continuous updates pattern, continuous updates. In batch updates, important features wait for the non-important features. How do we solve it? We implement continuous updates. When we actually send an update, once we have a feature ready, without waiting for other features to batch them together, just because features can be prioritized differently, and there is no reason for phantom braking fix to wait for the chess. But let's take another example. This time it will be mobile. Mobile, this is Android, applies one-to-one to Apple. The story is actually about that. So those guys do everything right. They now not force us, but recommend us to have the auto updates on. We go to sleep, we wake up tomorrow morning with a completely different version of Twitter with the edit capabilities. And here's a story about a game that was developed by a developer who actually was very good in documenting their experience. They just got started. It was the Noob Adventure, I think, has dual meaning here. It's a noob in the game, but it's also an adventure of the developer who wrote the game, and they actually documented it very, very well. So one of the things there that they spoke about was they decided to implement a new feature, and this feature was monetization, like in-app purchases for getting rid of the ads. And they used templating. That was for Android. They used Java. For iOS, they use Swift. Both of them have templating with a $sign inside. And then when they actually tried their feature and they did testing on Apple's staging servers, the staging servers return prices without the $sign of the currency. So everything was great. But when they rolled out a new feature to production and people start updating it, some of Apple's production servers returns the price with the currency symbol, and some of the users suffered crashes when they tried to use this feature and purchase the game. Now, right, and it took time to understand what went wrong, because everything was perfect on staging, and also the behavior in production was mostly documented by users down-rating the app and writing angry comments instead of providing some useful information. So they went into research, they contacted the users who reported the crash and did some crazy stuff to understand what's going on, and obviously the non-predictive behavior of the servers didn't help, so it took them a while to even understand what went wrong, right? And the next problem is, after they realized what went wrong, it took time to get fixed through Apple Review, because there is no option of update in Apple, or even a rollback in Apple and in Android without releasing a new version. If I just want to roll back the misbehaving feature, I actually need to create a new version which is higher than the bug version. It can be completely similar to the one that I had previously, but it will still go through the review of Apple Store and Google Play Market. And this can take days, even expediting. Well, they have expediting this. We will do it in a couple of hours, but not on the weekend. Because, you know, we don't work on the weekend because it's weekend. So if you found the bug on Friday and you submitted it on Friday evening, the first chance you will get to actually get it approved will be midday Monday, because we have a queue, we're on the weekend, a lot of people submitted, we will take our time. So this is all a pretty horrible story. Continuous update pattern, canary release. The problem, we release a bug which affects all the users. And the continuous update pattern will be release to a small number of users and observe. If the problem occurs, stop the release, revert the update of the affected users. Right? This is what you want to do. Observability comes with it. There is no reason to do canary releases if you cannot observe the problem. And some problems are hard to trace, relying on user feedback. Your app sucks, it crashes, doesn't help me to find a problem in my app. And instead, you need to implement tracing, monitoring, and logging to achieve observability into your app and actually know what went wrong. Rollbacks are great because fixes might take time and users suffer in the meanwhile. Instead, implement a rollback, the ability to deploy a previous version without a delay, but then you run into platforms in which rollbacks are not available, so feature flags can help. Rollbacks are not always supported by the deployment target platform. Apple Store and Marketplace are two great examples, and then you actually embed two versions of the features in your app itself and trigger them with API calls, so you can do a canary release. Only a small amount of users will see the purchase button. The moment I understood through observability that something went wrong, I flip a flag, and now no one can see the purchase button anymore until I fix it, go in and get the new version through production. Right? So those are all come together in solving this problem. But you know what? How many of you are mobile developers? None of you? How about IoT? Not not really, so why the hell I'm wasting your time at 8:20 in the evening after a long day with IoT and mobile stories? Now, the problem is that they are not only IoT and mobile stories. And if you think that you are not mobile and IoT developers and your life is, you are the real developers, well, their life is much harder. The ability of the target is available for us, server-side developers, but not available for IoT. The state of target is well known to us. Those are servers in our control, but are not known to IoT. The version on the target is very valuable for us, but you have no idea from which version to which version the IoT folks are going to try and update. And the access to the target is well known. Those are servers, they are connected, but a solar array in Sahara might very well be disconnected when we want to do something, right? So if we kind of laugh at them or stupid IoT developers cannot do simple continuous updates, we are the last who can laugh about them because our life is easier and we still suck. And if you are not sure that we still suck, I will show it to you. Night Capital, this one John Willis mentioned this morning. This is one of the biggest fails of software update in the entire history of IT. That was a long time ago, but this is epic. Right, so new system reused some old APIs. Just they used some old field names in the server. One of 8 servers was not updated. They rolled out an update to 7 servers, so 7 servers used the new API, but the 8th still used the old API. And then new clients, 1/8 of them, sent a request to machine contained old code. And the same REST API triggered a completely different behavior on the old code, just because this is how it was. So what do? I mean, you roll out a new server, a new version, and you start to see like weird behavior. And this is money. We're talking about millions of dollars. What do? They shut down all the new servers, because obviously new servers misbehaving. So now 100% of the traffic goes to the only server that does the wrong thing. No monitoring, no alerting, no debugging. Now, think about it. Developers trying to debug a live, fast trading production system that loses tens of millions of dollars every minute that you try to fix it. I have shivering just thinking about it. I've been on call. That's unpleasant when your system is down. When your system is costing you tens of millions of dollars every minute. Long time short, they lost $400 million over the next 40 minutes until they understand what's going on, went out of business. And they were the second biggest trader firm in the Wall Street before this all started. So we have no excuse, right? Obviously, what we can learn from that is automate everything. People suck in repetitive tasks. This is why they should be trusted. Automate everything actually gives the machines the power to do this, and with machine deployment, that would never happen. Frequent updates. This system took them years to build and to deploy, so they didn't have the muscle. They didn't have the habit to deploy. Seldom deployment generates anxiety and stress, leading to errors. People suck. So update frequently to develop skill, habit, and muscle for updating. If you update 5 times a day, update is just like, so we update, why not? And then obviously you do it better. If it hurts, do it more. This is what they didn't do. State awareness. The decision of reusing old APIs on the server are obviously questionable. But sometimes target state can update the update process and the behavior of the system and even update. Even if you do have a good excuse, you still need to be aware of that. So know and consider target state when updating, and reverting might need reverting the state as well. this is something that is obviously very important. Another one. This is the CEO of Cloudflare. He was very upset on June 24 this year with Verizon that did some kind of update that actually affected the availability of Cloudflare, and he went online bashing their contractors. 10 days after, they went down by themselves. The internet wasn't very sympathetic. The only thing they said is, well, you cannot blame Verizon this time, can you? The pattern, real-life pattern, is you shame someone publicly, week later shit happens to you, don't do that. But their case is very interesting by itself. So what happened? New rules, that's firewalls, right? In the cloud, they deploy new rules all the time. This is how they battle the bad guys. Bad guys learn the rules, they change the rules. So new rules were deployed frequently to battle attacks. Deployment of a single misconfigured rule. regex to spike CPU to 100%. Next thing you know, in their status page, affected region Earth. Now, this is actually great because for me, it fortifies my belief that if this world is going to end soon, it won't be global warming or nuclear war or a meteorite hitting the Earth. It would be single regex that went wrong. Now I'm pretty sure. Okay, that was like that was a proof. What we can learn from that? Same things. Canary releases. Affected region Earth definitely shouldn't have happened. Releasing a bug affects all the users, release to a small number of users, reduce the blast radius, and then observe. If the problem occurs, stop this, revert back, etc., etc. Now, canary releases are something that we, if not born with this logic, are taught by our parents when we are 8 and start doing home chores. Because this is on each and every cleaning material. This is canary release. Before beginning any cleaning, always spot a test on a hidden surface. Take a small part and test. And if it doesn't work, don't do it on everything. Don't bleach your entire new dress before you try it if the color will go bad. This is something from age 8. And now Cloudflare, one of the most important and successful companies on the internet, don't realize how to bleach their dress. It doesn't make any sense. Well, this one is just ridiculous. Movie Pass, it's a service for going for movies for a fixed rate. You pay them some of money every month, and then you have unlimited tickets. And you basically go to movies. Well, several weeks for updating an app. I guess do 0 time instead of weeks, because if we do weeks, you will just lose all your users while you are updating it up. So zero downtime, over the L, small and frequent, continuous updates. This is how you do it, and not take your app for 5 weeks to do a software update. So with that, just summarize of the patterns that we learned. Frequent, automatic, tested. Well, we didn't speak about failures in QA, but you can imagine there are plenty. Canary releases, state awareness, observability, and then we have local rollbacks as an extra credit task. Local rollbacks are hard and nasty, and you know what? If you do everything else, I can forgive you if you don't do local rollbacks. But everything else, we have no excuse. This is basic ops stuff that we all know how to do, and we'd better start doing that. So with that, what we want to go is update available. Do we want it? It doesn't really matter, because we never have high risks, because we never have high risk, or we always trust the update. And the way that we always trust the update is the continuous update that I showed you. So our goal is to transition from bulk and rare software updates to extremely tiny and extremely frequent software updates. So tiny and so frequent that they provide an illusion of software flowing from development to the update target. Right? We call it the liquid software vision. We wrote a book about it, and by we, I mean yours truly and two amazing co-founders of JFrog, Fred Simon and Yoav Landman. And tonight you have a great opportunity to get the book. Steve is there just showing the books. We have plenty, and if you want to, I will be happy to sign it for you. One more thing, there are very seldom occurrences in which continuous updates do not make sense. It might be on stuff like you should avoid updates in certain times during surgery, for example. But those cases are very rare. Oh, I have a great question for you. What do you think updating a plane in flight, like its systems, its software systems, who thinks it's a bad idea? Okay, a couple of hands.
Nice idea. It's a necessary type of action you have to do. It actually updates itself every second with weather reports.
No, I mean like software, not data. Software. Who thinks it's a good idea? Well, one person. Steve, you know why it's a good idea. It is a good idea. And I truly believe that, updating the software of plane in flight is those 10% that we shouldn't do. We should let the plane safely land, and then update the software. But hey, how about now you have a hacker that sits in the economy class and actively attacks successfully the plane to hijack it and fly with it to wherever NotPetya is written in. What do you think now? Wouldn't it be wonderful to be able to patch this vulnerability, perform an update, and save the plane? Who thinks it's a good idea? This is how I convince you doing continuous updates for planes in flight, which is nice. With that, I'm here for, obviously, the followers on Twitter and the great feedback, so do that now. Just remind you, @Baruch on Twitter. Liquid software is a great hashtag that you really should use when you convince your friends to update their planes in flight. And liquidsoftware.com, that's our website, and jeffrog.com's show notes. This is where you find all the awesomeness. And with that, thank you very much.